Hey everyone, and welcome back for another deep dive.
It's great to be here.
Today we're going to be talking about asteroid mining, something that sounds like it's straight out of science fiction,
Right.
but it's becoming more and more of a reality, and
Yeah.
a lot of people are talking about it, and there's a lot of research being done, and
Yeah.
we thought we'd take a deep dive into all this material that we've got and really kind of unpack what this whole thing is all about.
Yeah, it's really interesting. The
Yeah.
amount of data that scientists are dealing with asteroid mining is
Oh yeah,
it's huge.
it's got to be astronomical.
Oh, it is.
Yeah.
It's amazing.
So how do they even know where to begin? Like,
Right.
if you were to just say, like, okay, let's go mine an asteroid, like, where do you even start?
It's like trying to find a grain of sand
Right.
on a beach,
Yeah.
except the beach is space
Right.
and the grain of sand is a valuable asteroid.
Yeah. So where does this data come from?
Well, it comes
Is it just like telescopes, or is there more to it than that?
There's ground-based telescopes that are taking pictures and using radar data,
Mm-hmm.
but we also have space telescopes like the NEOWISE telescope,
Okay.
which is really interesting because that can give us thermal imaging and spectral information
Wow.
without having to deal with the Earth's atmosphere.
Oh, right, because that distorts everything.
Exactly.
Okay.
And then even probes like OSIRIS-REx
Yeah.
actually landed on an asteroid and brought back samples.
That's incredible.
So we have a lot of information.
So it's not just about looking at it from afar. It's like actually going and grabbing pieces of it.
Yes.
Wow, that's amazing.
Yeah.
So you've got all this data coming from all these different sources.
Right.
It's almost like having a book written in like 12 different languages. You know, like how do you even
Exactly.
start to make sense of it all?
You got to translate it, you got to clean it up,
Mhm.
organize it so that
Okay.
it's usable.
So there's a lot of like data cleanup that has to happen before you can even get to the point of analyzing it.
Absolutely.
Yeah. Okay. So what does that process look like?
Well, first they have to remove outliers, measurements that are way off from the others that could skew the analysis.
It's like deleting the blurry photos so
Exactly.
you can focus on the good ones.
You got it. And then they fill in any gaps in the data, kind of like piecing together a torn up treasure map.
Okay.
And then they reduce noise, which is like smoothing out the data so you can see the important patterns more clearly.
So all of that's happening before we can even get to the part where they're analyzing it for, you know, the good stuff that's in there.
Right.
Okay. So once it's all cleaned up, then what?
Then comes the really fun part, which is applying machine learning algorithms to analyze that data
Okay.
to identify potentially valuable asteroids.
So this is where we're actually going to figure out which ones might have something that we're looking for.
Yeah.
Okay.
So you can think of these algorithms like a superpowered sorting hat from Harry Potter.
Right.
Instead of sorting students into Hogwarts houses, they're sorting asteroids based on their composition.
So like a platinum-rich asteroid versus just a rock asteroid or whatever.
Exactly. And some of the most common algorithms they use are support vector machines and random forests.
Right.
And those help to kind of classify these asteroids into different types.
Okay, so let's say we've identified one that looks promising.
Okay.
How do we then go from like, oh, that's an interesting rock,
Right.
to like, oh, that's a potential gold mine?
That's where predictive modeling comes in.
Okay.
So they use these really complex models to estimate the quantity and type of resources that are on an asteroid.
Okay.
And some of the types of models that they use are regression models, neural networks, and Bayesian models.
Okay.
And those help to give them a more accurate picture of what's actually on that asteroid.
So we've gathered the data, we've cleaned it up, we've analyzed it with all these crazy algorithms.
Right.
Is there a real life example of this that you could share?
Yeah, a really good example is the NEOWISE mission.
Right.
So they applied machine learning to the infrared data from NEOWISE,
Mm-hmm.
and they were able to classify over 10,000 asteroids.
Wow.
And they actually discovered a correlation between certain spectral signatures and the potential for valuable resources.
Wow. So it's like finding a treasure map in a sea of data.
Exactly.
That's incredible.
So now you're probably thinking, okay, great, we know what's on these asteroids, but how much is that actually worth?
Right. Like, is there a way to put a dollar amount
Exactly.
on
right.
space platinum?
Right. How do you put a price tag on a chunk of platinum that's floating in space?
Right. Is it just like whatever platinum's going for today, that's how much it's worth, or?
No, it's much more complicated than that.
Okay.
So scientists have to factor in things like the asteroid's volume, its density,
Mhm.
the composition to predict how much of that resource is actually there.
Hmm.
And then they have to look at market forecasts and try to predict what the demand and the price is going to be for that resource.
So it's like science meets economics.
Yes.
Wow, that's crazy.
So it's a very complicated process.
So we found the asteroid. We know it's valuable.
Right.
Do we just launch a mission and start digging?
Well, not quite.
Okay.
There are a lot of other things to consider, like how accessible is that asteroid?
Right.
What technology do we need to extract those resources?
Hmm.
And what's the environmental impact going to be?
So just because it's there and it's valuable doesn't necessarily mean it's feasible
Exactly.
to get to it.
Right.
Okay. So before we dive into that, I think we need to take a quick break.
Okay.
We'll be right back to continue our discussion on asteroid mining.
Sounds good.
Welcome back, everyone.
Yeah, it's exciting stuff.
So before the break, we were talking about like finding these asteroids and figuring out which ones have the good stuff.
Right.
But like you were saying, it's not as easy as just like going and grabbing it.
No, not at all.
There's more to it than that.
It's a huge challenge.
Yeah. So what are some of those challenges like?
Well,
What are the things that are preventing us from just like sending a spaceship up there and grabbing it?
first of all, these asteroids are really, really far away.
Okay.
I mean, millions, sometimes hundreds of millions of miles away.
Yeah, we're not just talking about like a trip to the moon here.
No, this is a whole other...
It's a serious
This
business.
is the big leagues, yeah.
Okay.
And then you have to consider the environment of space, which is brutal.
Okay.
I mean, extreme temperatures, radiation, micrometeoroids, which are these tiny little particles of space debris that travel at super high speeds.
Wow.
So anything you send up there has to be able to withstand all that.
It's got to be a tough spaceship.
Oh, yeah.
Okay, so we've got distance and we've got just the harshness of space.
Right.
What else?
And then there's the challenge of actually extracting the resources from the asteroid.
Okay.
I mean, asteroids come in all shapes and sizes. They're
Right.
made of different stuff.
You can't just bring one giant drill and expect it to work on every asteroid.
Nope. You got to be a lot more creative than that.
Okay, so what are some of the things that they're thinking about using?
Well, one idea that I find really interesting is optical mining.
Optical mining, what is that?
So basically, they use concentrated sunlight
Yeah.
to vaporize material from the surface of the asteroid.
So it's like a giant magnifying glass in space.
Kind of, yeah.
Wow.
So it's really precise. You don't even have to touch the asteroid,
Okay.
which minimizes the risk of, like, damaging it or anything.
So you're basically like melting the asteroid.
Yeah, you vaporize material and then you collect it.
And then you just scoop it out.
Exactly, yeah.
Wow. Okay, so that's for like certain materials.
Right, that works well for volatile substances like water.
Okay.
But if you're trying to get something like metals,
Yeah.
you'd probably need a different approach. Something like surface mining.
So like more traditional like digging and drilling?
Yes, but with robots?
Robots. Okay, I like where this is going.
Yeah, so you'd have these robotic excavators or drills that are designed to work in the low-gravity environment of an asteroid.
So we're talking like a whole team of robots going up there and like mining this thing.
Exactly like little ants
Wow.
on a giant anthill.
That's awesome.
Yeah.
Okay, so we've got optical mining, we've got surface mining with robots. Are there any other kind of cool techniques?
There's also shaft mining, where you dig tunnels or shafts into the asteroid
Okay.
to access deeper resources.
So it's like real mining just in space.
Yeah, exactly.
Wow.
So you can imagine a lot of different scenarios depending on the asteroid and the resources you're trying to get.
So this is a whole new field of engineering then.
Oh, absolutely.
Building robots that can operate in space and withstand all these conditions.
Yeah, and it's happening right now. I mean, companies and space agencies are already developing and testing these things.
Wow.
Like planetary resources, for example.
Hmm.
They've developed a series of spacecraft called the Arcid series that are designed to prospect and analyze near-Earth asteroids.
So this is not just like on paper. This is real.
It's happening.
It's becoming a reality.
Wow. So as we get closer to actually mining asteroids,
Right.
we got to talk about, like, legal stuff.
Oh, yeah,
Like, who owns all this stuff?
Exactly.
Is it just like a free-for-all, or are there rules?
That's a great question, and that's something that legal experts and policymakers are wrestling with right now.
It's like the Wild West of space.
Kind of, yeah. It's a new frontier
Yeah.
with all the potential for conflict and, people trying to take advantage of the situation.
So we got to be careful.
We got to be very careful.
Yeah.
We need to establish some clear guidelines and regulations.
So it's not just about the technology, it's about the ethics and the legal side of things, too.
Absolutely.
Wow. It's a lot more complicated than I think most people realize.
It is, yeah.
It's not just about sending a spaceship up there and grabbing a rock.
No, it's a lot more nuanced than that.
Yeah, we got to be responsible about this whole thing.
Absolutely.
Yeah.
We have to consider the environmental impact.
You know, we don't want to damage these celestial bodies.
We don't want to pollute space.
Exactly, or disrupt the balance of the solar system.
Yeah, so it's a big responsibility.
It is a huge responsibility.
And it's not just about us. It's about, future generations
Yeah.
and the whole, ecosystem of space.
Exactly.
Wow. It's really fascinating, but also kind of daunting.
It is, yeah, but I think it's an endeavor that's worth pursuing.
Yeah, I mean, the potential is huge
The potential is incredible.
to revolutionize space exploration, to create new industries, to potentially even solve some of our resource problems here on Earth.
Exactly. And as we develop new technologies and gain more experience in space, the economics of it are only going to get better.
Right. What seems impossible today might be commonplace in a few decades.
Right, exactly.
Oh.
So it's definitely something to keep an eye on.
Right, so we've covered a lot of ground today. We've talked about the challenges of asteroid mining.
Right.
We've talked about some of the techniques.
Mhm.
We've talked about the ethical considerations.
Yeah,
It's a lot to take in,
it is.
but I think it's important to have these conversations.
Absolutely.
So before we wrap things up, let's take another quick break and we'll come back with some final thoughts on the future of asteroid mining. Welcome back to the Deep Dive. We've been talking about mining asteroids and how we even figure out which ones to go after.
Right, and all the technology and the challenges.
Right, so now the question is, how do we actually make this profitable?
Yeah, that's the billion-dollar question.
Right, because all of this stuff costs money, like sending spaceships and
Yeah,
building robots and
it's a huge investment.
yeah. So how do you even begin to calculate like the return on investment for something like this?
Well, it starts with choosing the right target.
So not just any asteroid will do.
No, you have to be very strategic about it.
Okay, so what are some of the things that make an asteroid a good target?
Well, obviously the concentration of resources is important.
Like how much of the good stuff is actually there?
Exactly. And then
Yeah.
you have to consider how easy it's going to be to extract those resources.
So some asteroids might be harder to mine than others?
Right. Some might be more porous or have a different composition that makes it more challenging.
Okay, and what else?
And then proximity to Earth is a big factor.
Oh, right, because the further you have to go,
The more expensive it's going to be.
yeah, fuel and time and all that.
Exactly. So an asteroid that's closer to Earth is going to be more attractive from an economic standpoint.
So it's kind of like space real estate.
Yeah, you could say that location, location, location.
Okay, so we've got to pick the right asteroid, but then we also have to think about what we're actually mining.
Right. Different resources have different values.
So platinum is obviously very valuable.
Yes, very much in demand.
But what about things like water?
Water is interesting.
Yeah,
It might not be as valuable per unit as something like platinum,
right,
but it's essential for life support.
right. If we want to have people living in space.
Exactly. And it could also be used as fuel. So if we can find a way to extract water from asteroids, that could really open up the solar system to exploration.
Because we wouldn't have to bring it with us.
Right, exactly.
Wow. So that's pretty amazing.
Yeah, it's a game changer.
So asteroid mining is not just about getting rich. It's about, like, expanding our reach into space.
It's about pushing the boundaries of what's possible.
Yeah. Okay, so I'm getting really excited about this.
I know, it's exciting stuff.
But we have to talk about the potential downsides.
Right.
Like, are there risks involved with asteroid mining?
Well, one of the biggest concerns is the environmental impact.
Okay.
We have to be very careful that we don't disrupt the balance of the solar system.
So we don't want to create like a space debris problem or...
Right, or accidentally knock an asteroid off course.
Right. That would be bad.
Yeah, that could have catastrophic consequences.
So we have to be really thoughtful about how we approach this.
We have to develop sustainable mining practices.
Yeah.
And minimize our impact on the space environment.
And then there's also the legal and ethical questions.
Right, who owns these resources?
Right.
How do we make sure the benefits are shared equitably?
It's a lot of big questions.
It is. It's a whole new frontier.
Yeah. So it's exciting, but it's also a little bit scary.
It is, but I think it's a challenge that we're up to.
Yeah.
I think we can figure this out.
Well, it's been an amazing journey learning about asteroid mining with you today.
It's been a pleasure.
I feel like we've just scratched the surface, though.
Oh, yeah, there's so much more to explore.
But I think this is a good place to wrap things up for now.
I agree.
So for everyone listening, thank you for joining us on this deep dive into the world of asteroid mining. And keep looking up.